The last thing we're going to practice are x and y intercepts, and then we're going to put this all together and graph a rational function. So your x-intercepts occur when y equals 0 or f of x equals 0. And it goes on to say that for a fraction, we are going to let the numerator equal 0 and solve for x. It does say that x-intercepts are the real zeros of the numerator written in lowest terms. You do want to make sure you cancel anything out that you can before you set the numerator equal to 0. And then y-intercepts occur opposite when x equals 0. So therefore, you're going to plug in 0 for your x and then simplify to get your y. So let's do these 3 examples as some practice. Find the x and y intercepts, write as an ordered pair. Okay, first thing we want to do before we find x-intercepts is make sure this is in lowest terms. The top, we have a GCF of 5. So I'm going to pull out my 5. And I get 5 times x plus 2. And then I can't do anything to the bottom. And so I can see here it doesn't simplify. So this is in lowest terms, or this is also in lowest terms, just wrote in a different form, but these are both the same. So now I'm going to take my numerator and set it equal to 0 to find my x-intercept. I'm going to take my numerator of this top one right here. I'm going to subtract my 10 over. And then divide by 5 to get x equals -2, which is what we would have got right here if we would have done x plus 2 equals 0, would have got -2. Now, because we want to write these as ordered pairs, this is not done. So let me state that my math lab, I think usually will just say x equals and you're putting in -2. But to me, this is a vertical asymptote. That's an equation of a line. So for me, I want these as ordered pairs. So therefore my x-intercept is at -2, 0. Now your y-intercept, we're going to plug in a 0 for your x and simplify to get y. So I've got y equals 5 times 0 plus 10 all over 0 minus 5. Well, that cancels. So we're just left with 10. That cancels as well. So we're left with -5. And so we get -2. My math lab just wants x equals -2, and that's fine. But I want ordered pairs. So the x-intercept is at 0, -2. Okay, practicing again. Write this in lowest terms, and I can't do anything with the top or the bottom. So to find the x-intercept, let the numerator equal 0. My numerator here is just 1. So I have 1 equals 0. Well, this doesn't make sense. And so what that tells me is that I have no x-intercepts. But I will have a y-intercept. So here to find my y, we plug in a 0 for x and simplify. So I get y equals 1 over 0 plus 7 to get 1 over 7. So if we write that as an ordered pair, my y-intercept is at the ordered pair 0, 1/7. Okay, and then lastly here in part C, the top is already factored for us, the bottom is not. I'm going to rewrite the top. And then the bottom is the difference of squares. So the square root of x is x. The square root of 4 is 2. And because it's minus 2, that is 1 plus and 1 minus. Okay, so once I write it like this, I can see very clearly that nothing cancels. When you have it wrote like this, it's kind of tempting to mark out your x plus 4s, but that's an x squared, right? So don't mark those out. So now we need to take the numerator and set it equal to 0. Because, well, they both have x plus 3 and x plus 4 equal to 0. So this one gives me that x equals -3, and this one here gives me x equals -4. So my x-intercepts are at -3, 0, and at -4, 0. Okay, and then my y-intercepts, this is what I was about to say before. It doesn't matter which version of this you take to plug in to solve for your y. If I take this one here that's squared, we have 0 squared minus 4. Wait, what am I doing? We need to plug it into everything, don't we? Sorry. Not just the bottom. Okay, so let's take this version here. And we have 0 plus 3, 0 minus 4, all over 0 squared minus 4. So 0 plus 3 is just 3. 0 minus 4 is -4. So we have 3 times -4 to give me -12. 0 squared is 0. So we're just left with -4. And goodness, if this wasn't the end of the video, I would start over. I've messed up a little bit again. This is x plus 4, and I wrote it as x minus 4. So now when I multiply, I'm multiplying 3 times 4 to get a positive 12. And so we get -3. Whew. Look at the math. Don't listen to what I said on that one. So therefore, my y-intercept is at the ordered pair 0, -3. Now I have some bonus questions here on C, but before we get to those bonus, I do want you to kind of notice the pattern that happened here. On all of these, we had one y-intercept every single time because this is a function. We will have a y-intercept unless I have a vertical asymptote along the y-axis. Okay, but every other time, we have a y-intercept. Your x-intercepts can vary. You can have 1, you can have none, you could have 2, and honestly, you could have even more than 2. Okay, so these are going to change between none, 1, 2, and also, possibly more than that. So, but that y-intercept should always be 1. Now, these bonuses are going to tie back in what we did at the beginning, our vertical asymptotes, and what we did last video, our horizontal and oblique. And this is kind of what we're going to be needing to do next video when we're graphing, is putting it all together. So let's kind of review. Find the vertical asymptote. You find the vertical asymptote when r of x is in lowest terms, set the denominator to equal 0. So you can do either of these here to equal 0, either x squared minus 4 or this in factored form. If I take this in factored form, Here I get x equals -2, and here I get x equals 2. See how similarly these are wrote? It's hard to determine that I'm talking about x-intercepts here and vertical asymptotes here when it's wrote in the exact same form. So that's why we like to write these as ordered pairs. So now this tells me that I have vertical asymptotes at x equals -2 and x equals 2. Then for horizontal asymptotes, we need to compare our n and our m together. Well, I can compare my n on this bottom one. I know my m is 2. What's hard to tell is my n based off of these forms here. So if you notice, x times x gave me x squared. So therefore, if I multiply these x's together, we would also get x squared. And then I don't know what happens after it, and it's not really important either. So now that I know x times x is x squared, that tells me my n is also 2. So here we are talking about case number 1, since they are equal. And case number 1 says to use the ratio of the leading coefficients. This is the same as 1x squared over 1x squared. So we have a horizontal asymptote at y equals 1.